Today, we're diving deep into a condition that affects millions upon millions of women, uterine fibroids. We're going to unpack what they are, where they come from, and why they're such a big deal. So, let's get right into it.
Let's just start with this one powerful fact, because it really sets the stage. Uterine fibroids are not some rare, obscure condition. Nope, they are the most common pelvic tumors found in women. That right there is why understanding them is so absolutely critical.
So what are we actually talking about here? Well, the medical term is leiomyoma, but the most important word on this slide is benign. That means they are not cancerous, and they grow from the myometrium, which is just the technical name for the strong, muscular wall of the uterus.
Here's our game plan. We're going to start with the basics, then we'll dig into their cellular origin story. It's pretty fascinating. After that, we'll look at the hormone connection that makes them grow, examine what they actually look and feel like, and finally, we'll see how they're classified based on where they live.
All right, first things first, let's lay down the foundation and make sure we've got the basics covered.
So let's just break this down one more time. We've established they're the most common non-cancerous tumors of the uterus. We know they come directly from that muscular wall. And this last point is really important. Studies consistently show they are much more common in African American women, which highlights a major health disparity that researchers are working to understand. Okay, so we know what they are, but where do they start? I mean, how does this whole process even begin? To figure that out, we have to zoom way in, all the way down to a single cell.
Now this is where it gets really interesting. Fibroids are what scientists call monoclonal, and that's a fancy way of saying that an entire tumor, no matter how big it gets, grew from one single original cell that went a little rogue. Think about that. One cell is the ancestor of the entire thing.
So the obvious next question is, what makes that one cell go off script? Well, the clues are pointing towards genetics. Scientists have found some specific glitches in the genetic code, like material getting swapped on chromosomes 12 and 14, bits of chromosome 7 going missing, and mutations in very specific genes. These are the kinds of genetic triggers that are thought to kick the whole process off.
So a genetic trigger might plant the seed, but what acts like fertilizer? What makes them actually grow? Well, for that, we need to talk about the powerful influence of hormones.
This quote really just cuts right to the chase. Fibroids depend on hormones to grow, and the main fuel for their fire is estrogen. You could almost say they feed on it. They absolutely thrive in a high estrogen environment.
And here's the kicker. It's a vicious cycle. Fibroids don't just sit back and wait for estrogen to show up. They actually create their own personal high estrogen paradise. It's brilliant in a way. First, they pack themselves with extra estrogen receptors, so they're like magnets for it. Second, they're bad at breaking down the strongest form of estrogen, so they keep the good stuff around. And third, they produce an enzyme that literally makes more estrogen right on site. It's a self-fueling machine.
And this is where the science connects to real life. When you look at the risk factors on the left, things like obesity or starting your period early, they're all tied to having more estrogen exposure over a lifetime. And then you look at the protective factors on the right, and you see conditions linked to lower estrogen states. The pattern is crystal clear. More estrogen generally means a higher risk.
Okay, we've covered the genetics and the hormones. Now, let's get physical. Let's examine the fibroid itself. What does it actually look and feel like if you were to see one?
So doctors describe them as round, firm, and kind of rubbery masses. And if you slice one open, you see this really unique whorled pattern. It almost looks like the grain in a piece of wood. And they're wrapped in what's called a false capsule, which is just compressed muscle tissue from the uterus that gets pushed aside as the fibroid grows.
Now that false capsule is incredibly important when it comes to surgery. It creates this natural line of separation between the fibroid and the healthy uterine wall. It's what allows the surgeon to go in and essentially shell out the fibroid while leaving the rest of the uterus intact. It's a huge deal.
Their plumbing is also pretty interesting. The blood supply flows from the outside of the fibroid inward. This means the very center gets the least amount of blood. So as a fibroid gets bigger and outgrows its own blood supply, the center is the first place to start breaking down.
All right, on to our final section. We're going to play detective again and profile these tumors. Because when it comes to fibroids, their symptoms and how they're treated often comes down to one thing: location, location, location.
And as you can see, they're not all in the same spot. The vast majority, a whopping 75%, are intramural, which just means they're growing inside the muscular wall. About 15% are submucous, and only about 5% are subserous.
This diagram shows it perfectly.
You've got the subserous fibroids growing on the outside of the uterus, you've got intramural ones chilling inside the wall itself, and then you have the submucous fibroids, which bulge inward into the uterine cavity. And you can probably guess, those are often the ones that cause the most trouble with bleeding and fertility.
And for those troublemaking submucous fibroids, doctors need even more detail. There's a special classification system just for them, which grades them from 0 to 2 based on exactly how much of the fibroid is poking into the cavity. That little detail changes everything when it comes to planning a surgery.
This table here shows the whole shebang, the comprehensive system that doctors use all over the world. It's like a universal language that allows them to classify every single type of fibroid with incredible precision, from its exact location to how it's growing.